So with these types of questions, you're always looking to see how to reorganize that expression. Sometimes you can perhaps relate it to that. That's not the case here, but those are the things you're suspecting. And you're thinking you're looking at identities and you're looking at combining these terms. So that's what we'll try to do here. So first I'm going to merge the 4x squared and 4xy term. And we sort of know that this will come up in the square of that, because if you square this, you will get those two pieces here. So that's kind of the starting point for that question, is to take those two terms and replace it with that square. So if I replace that, I have to, of course, subtract the y square. So essentially, that piece is the same as that. Now I'm left with 4y squared minus 6y plus 3 equal to 0. And I'm going to merge these remaining terms and see how those could be potentially rearranged. And sometimes it's also a matter of luck in terms of spotting these things. And if you note, if I factored that 3, that also becomes immediately clear that that's a perfect square. So this type of a approach for questions where we're kind of writing these as the sum of perfect squares is a common approach for many of the questions on CAT. So here you'll note that this is square, so this will always be greater than or equal to 0. That's also greater than or equal to 0. Since we need both of these to add up to 0, the only way that will happen is when each one of these pieces is equal to 0. So our condition is 2x minus y is 0, and y minus 1 is 0. That means y is 1, and we can figure out what 2x is from this by replacing y with 1. So we have our solutions, and to compute that, now it's just about just simply plugging that in and you'll get 7. So this seems easy, but I did not do it this way in the exam, under test conditions, I should say. I took a different approach. I wasn't able to see this, and this is going to happen in the real exam. So I'll just share with you how I actually did it after sort of abandoning different approaches that I took. So what I did was I rewrote this as a quadratic in x. So 4x squared, so then this piece becomes constant. 4y squared minus 6y plus 3 equals 0. So then I said I will just use the quadratic formula to isolate what x is. So this is, I'm applying ax squared plus bx plus c. So this whole thing is c. b here is minus 4y, a is 4, and then c is this piece. So I'll just apply that straight. So 4y plus or minus square root of square root of minus 4y squared minus 4ac. So 4 times 4, and then c is that part. So obviously this is messier, and I just I knew that maybe I don't want to go in this direction, but I just couldn't figure out any other way. So I'm going to pull out, so this becomes 16y squared, and I'm going to pull out a 16, so that's going to become a 4. So this, of course, you have to be careful when you're doing this kind of a factoring, that you're not making a mistake, and that 16 pulls out. Then 8, and then I'll knock out the 4, so that's 2, and then I'll just clean this up. Y squared minus 3y squared plus 6y minus 3, so that becomes actually minus 4y squared. I was already combining these two. So minus 3y squared plus 6y minus 3, and then if you factor out a minus 3, you get y squared minus 2y plus 1, which then I immediately notice that's the perfect square. So let me plug that back in. Minus 3, and then y minus 1 squared over 2. Now note, in the question they said both x and y are real. And so that means, and y minus 1 squared is always positive, minus 3 is negative. Well, x won't be real. In this case would be imaginary because of that minus there. So the only way that x can be real is if y minus 1 is 0, because then this piece would be 0, x would be real. and that would happen when y is 1, and then x would be equal to y over 2 or half. So same as earlier. So this is the approach I took. It seemed messy and kind of risky because anytime you go in this direction where things are kind of getting, I guess, too tedious, you're heading in the wrong direction. But it kind of eventually cleaned up. The other approach I also did try was trying some numbers to just see if I could plug in y equal to 0. But when you do that, x doesn't come out to be real. And that later on, that's when you realize that this is the only set of values that would satisfy that equation. And that's obviously very difficult to guess as a solution. So these are the two methods. I'm sure there are other ways to do it, but this kind of is the setup, is what the writers are expecting. So anytime you see these types of expressions, look to link them up with the standard identities and try to create perfect squares and then equate them to 0 if that sum has to be 0. So to summarize, the answer is 7.